chemistry classes. In this video, we are going to discuss about isomerism in coordination compound. Isomerism in coordination compound. Isomerism mean different compounds have same molecular formula, but they have different structure, hence they have different physical and chemical properties. Okay, this type of molecules are called isomers, and this phenomena called isomerism. Isomerism in coordination compound. Isomerism in coordination compounds we can classify two types. Okay, there are two types of isomerism in coordination compound: structural isomerism and stereoisomerism. Structural isomerism and stereoisomerism. These are the major classification of isomerism in coordination compound. Structural isomerism, again there are different type of structural isomerism. Ionization isomerism, ionization isomerism, hydrate isomerism, linkage isomerism, coordination isomerism, ligand isomerism. Okay, structural isomerism we can classify ionization isomerism, hydrate isomerism, linkage isomerism, coordination isomerism, ligand isomerism. Stereoisomerism. Stereoisomerism again we can classify geometrical isomerism and optical isomerism. Okay, here stereoisomerism mainly differ their spatial arrangement of the molecule. Molecules have same molecular formula, but they have different three-dimensional arrangement, 3D arrangement. Okay, this is related to stereoisomerism. So let us discuss more details about all this isomerism with example. Okay, next one we have to discuss here more details about structural isomerism. Structural isomerism. First one, ionization isomerism. Look here, these are two examples for ionization isomers. Ionization isomers mean they have same molecular formula. Okay, this you can see here cobalt. This is one example. Okay, these are one pair of compound. They have same molecular formula. Here both contain cobalt. Okay, here bromine. Here also bromine. Here 5NH3 molecule. Here also 5NH3 molecule. Here SO4. Here SO4. So here this pair of compound they have same molecular formula, but after ionization they form different ions. Look here, this is positively charged ion. We know here this is coordination entity. This is coordination entity, and this forms negatively charged ions. Okay, always in molecules outside the coordination sphere they form negatively charged ions. So these two coordination compounds after ionization they form different ions. Okay, this is positively charged ion and they are negatively charged ion. This type of isomerism called ionization isomerism. Ionization isomerism mean molecules they have same molecular formula, but they form different ions after ionization. Okay, also you can see here more example for ionization isomerism. Clear? After ionization isomerism, next one we have to discuss here solvent or hydrate isomerism. Look here, solvent or hydrate isomerism. Solvent or hydrate mean it represent water molecule. Okay, water molecule. Solvent or hydrate isomerism mean here you can see here they have same molecular formula. They have same molecular formula. We know this is coordination sphere. Ligands inside the coordination sphere they are directly attached to central metal atom. They are secondary valency. They are directly attached to central metal atom. You can see here 6 water molecule directly attached to central metal atom. Here 5 water molecule directly attached to central metal atom. They have same molecular formula, number of chromium, water molecule and chlorine in each compound. This is coordination compound 1, this is coordination compound 2. You can count here number of chromium atom, water molecule and chlorine, each case same. 5 water here 6 water molecule, here also 5 plus 1 6 water molecule, here 3 chlorine, here 1 chlorine, here 2 chlorine, so 3 chlorine atom, here also 3 chlorine atom. So each compound which contains same number of atom means they have same molecular formula, okay, but number of water molecules directly attached to central metal atom, it is different, okay. So here hydrate or solvent isomerism mean molecules they have same molecular formula but they are differ in direct attachment of solvent molecule, okay, direct attachment of solvent molecule. Solvent molecule mean water molecule. Direct attachment of solvent molecule to the central metal atom is differ but they have same molecular formula. This type of isomerism called hydrate isomerism, okay. So you can see this is one example for hydrate isomerism and you can check here more example for hydrate isomerism. Clear? Okay, next one we have to discuss here linkage isomerism. Linkage isomerism. See here, these are the example for linkage isomerism. This pair of coordination compounds are example for linkage isomerism. Here this pair of compound they have same molecular formula, okay. Here cobalt 5NH3 and NO2Cl2. Also here cobalt 5NH3, here Cl2 and here NO2. Actually nitrogen and 2 oxygen, it is NO2, okay. But the mode of attachment of ligand to central metal atom is differ, okay. Mode of attachment of ligand to central metal atom is differ, okay. NO2 mean here nitrogen attaching with the central metal atom. ONO mean here oxygen directly attached with the central metal atom. So mode of attachment of ligand to central metal atom is differ, okay. We know if there is NO2 we will say nitrito N. Here ONO we will say nitrito O, here nitrito N, okay. This is another type of ligand. This also here mainly ambidentate. We know ambidentate ligands. Ambidentate ligands are coming in linkage isomerism. Ambidentate ligands. So here NO2 ONO, this is ambidentate ligand. CN and NC. If there is CN, we know cyano. CN cyano. NC mean nitrogen directly attaching with the central metal atom. It is isocyano. CN cyano, NC isocyano. Look here, this is another type of ambidentate ligands, SCN and NCS. SCN thiocyaneto, that is SCN. NCS mean isothiocyaneto. Okay, so these are different ambidentate ligands. Ambidentate ligands involve linkage isomerism. Linkage isomerism mean here mode of attachment of ligand to central metal atom is differ. Clear? Also here we have, so look here, this is example for linkage isomerism. After linkage isomerism, next one we have to understand here ligand isomerism. Ligand isomerism. Ligand isomerism mean here molecules they have coordination compound, they have same molecular formula, but the structure of ligand in coordination entity is differ. Structure of ligands it will be differ. Okay, look here CH3 CH2 CH2 NH2. This is N propyl amine. N propyl amine CH3 CH2 CH2 NH2. Here this ligand is N propyl amine. Okay, and here these two pair they have same molecular formula, manganese H2O 5 times. Also you can see here 3 carbon NH2. Here also you can count number of carbon and hydrogen will be same in both. Okay, but you can see here this is chain compound and this is branched compound, CH3 CH CH3 NH2. Okay, so here this is isopropyl amine. This is branched one and we will name this isopropyl amine. This is N propyl amine. Okay, this is chain 1 N propyl amine. This branched one isopropyl amine. Clear? So here ligand isomerism mean coordination compounds they have same molecular formula, but structure of ligand in coordination entity will be differ. Structure of ligand in coordination entity will be differ. Clear? So these are ligand isomerism. So here we discuss linkage isomerism. Linkage isomerism mean molecules they have same molecular formula, but mode of attachment of ligand to central metal atom will be differ. Okay, generally ambidentate ligands involved. The coordination compounds which contain ambidentate ligands shows linkage isomerism. Next one, ligand isomerism. Ligand isomerism mean molecules coordination compound they have same molecular formula, but structure of ligand in coordination entity will be differ. Clear? Okay, so here we discussed structural isomerism. Next one we have to discuss here stereoisomerism. Stereoisomerism, we know stereoisomerism again classified geometrical isomerism and optical isomerism. Okay, so here we have to discuss here geometrical isomerism. Generally geometrical isomerism shows heteroleptic complex generally shows geometrical isomerism. We know heteroleptic complex and homoleptic complex. Heteroleptic complex generally shows geometrical isomerism. Okay, also geometrical isomerism, the coordination compound with coordination number 6 or coordination number 4 generally shows geometrical isomerism. Okay, coordination compounds with coordination number 6 or coordination number 4 shows geometrical isomerism, or you can say heteroleptic complex shows geometrical isomerism. Clear? So here we have to discuss here different type of geometrical isomerism. Okay, first one we have to discuss here coordination number 4, complex with coordination number 4. Okay, coordination number 4. So here generally coordination compound, coordination number 4, coordination compound with coordination number 4, there is tetrahedral and square planar. Generally square planar complex shows geometrical isomerism. Okay, coordination number 4, square planar complex shows geometrical isomerism. Okay, so here there are different type of geometrical isomerism with square planar. Okay, so we can classify this. First type, Ma2X2 coordination compound. Here first category, Ma2X2. Here this M represent central metal atom, and here A represent one type of ligand, X represent another type of ligand. Ma2X2. M mean central metal atom. Here A2 mean same type of two ligand. X2 mean another same type of two ligand. Okay, Ma2X2. Example for this. Look here, platinum Cl2 NH3 twice. Okay, so this is one coordination compound. Okay, it is example for A2X2. Okay, so here this is one example for Ma2X2. Look here, this type of ligand shows cis-trans isomerism. Cis-trans isomerism means same type of atom or same group of atoms coming same side, that is cis isomer. Same type of atoms coming different side, that is trans isomer. You can see here chlorine, these are same side, so this is cis isomer. Here same type of atoms are opposite side, so this is trans isomer. Okay, so here we discuss stereo isomerism. There are two different type of stereo isomerism. Geometrical isomerism and optical isomerism. Geometrical isomerism and optical isomerism. Geometrical isomerism generally shows coordination number complex with coordination number 6 or 4. So here first we are talking here coordination number 4. Okay, coordination compound with coordination number 4. Okay, first type Ma2X2. This type of compound shows cis and trans isomer. Cis isomer means same type of atoms coming same side, it is cis isomer. Same type of atoms coming opposite side, this is trans isomer. Okay, this is example for Ma2X2. Okay, next one we have to discuss here second type of isomer. Already we discussed first type of geometrical isomerism. Here it is Ma2X2. Next one we have to discuss here MABCD. MABCD means central metal atom, then 4 different ligands. A, B, C, D. 4 different type of ligand. This is also square planar complex. Okay, example for this type of ligand MABCD. Here central metal atom platinum, NO2, pyridine, NH2OH, NH3. Here 4 different type of ligands with platinum. This is example for MABCD. Remember, this is also square planar complex. Also this type of coordination compound produce 3 isomer. Okay, remember MABCD, this type of ligands produce 3 different type of isomer. Clear? Now see here, this is one type of arrangement. Okay, here central metal atom A, B, C, D. This is one set. Okay, here second type. Here C and B will be flip. Okay, after flip this B and C, this B coming to up and B will be on the top and C coming to down part. Okay, now see here B and here C. You can check here B over here top and C down. So this and this are isomer. Okay, and this is third arrangement, central metal atom A, B, C, D. This arrangement totally different from this and this. So this is third isomer. Okay, and look here, when you flip B and C, here we flip C and B, we got second type of isomer. Okay, then we did here third type of isomer. When you flip B and C, This C will be on the top. Here C bottom part, here C up. Okay. But these two are not different isomer. These two are identical. These two are identical. Why these two are identical? Look here A. Okay, when you consider diagonally here A and D. Okay, here also A and D, they are same. If it is coming like this, it will consider like identical isomer. But when you consider this and first two isomer, here A and B, but here A and C, not same. So they are different isomer. But this case here A, D and here it is AD. So this is considered only one isomer. Okay, they are identical. So here 1, 2, 3, 3 isomer. So here we discuss this is second type of isomer, set A, M, A, B, C, D, central metal atom and 4 different ligand. Example this ligand. Okay, this is also square planar complex. Okay, and another thing you have to remember, A, B, C, D, this type of coordination compound produce 3 isomer. Okay, so these are the arrangement. So you have to remember here diagonally it will be different. Clear? Okay, next one we have to understand here geometrical isomerism in didentate ligands. We know didentate ligands or bidentate ligands mean ligands which contain 2 donor atoms. Okay, example for didentate ligand, ethylene diamine which contain 2 donor atom. Here this nitrogen and here this nitrogen. There are 2 nitrogen in ethylene diamine. So it is bidentate ligands. Okay, so look here bidentate ligands. Okay, so one EN it contains 2 donor atom. Here 2 ethylene diamine. So 2 ethylene diamine. Okay, so both of them contain 2 donor atom. Okay, also there is 2 Cl2. So totally 6 bond will be there. There will be 6 bond. Okay, so here this type bond coming coordination number 6. So here geometrical isomerism which contain didentate ligand. Example here cobalt Cl2 ethylene diamine twice. Okay, so here you can say here this type of isomerism coming coordination number with 6. Okay, and this is example for this. Here cobalt central metal atom and 2 chlorine and here ethylene diamine each side. Look here ethylene diamine. This is ethylene diamine. There are 2 bond. Here 1 bond and another bond. Okay. Here this is ethylene diamine. From 1 ethylene diamine there is 2 bond to central metal atom. Because it is didentate ligand, there are 2 bond from 1 ethylene diamine. 1 ethylene diamine making 2 bond. Okay, 2 bond with 1 central metal atom. And see here this is another ethylene diamine. This also making 2 bond with 1 central metal atom. And here chlorine coming this position. Okay, here up and down position chlorine coming, and here each side there is ethylene diamine. This type of isomers are trans. So you remember here up and down same type of atom, then it will be trans, not cis, trans. Okay, and here look here up and down not same type of atom, so this will be cis. So you can remember like this. Okay, before you learn same type of atom same side it is cis, but in this case here up and down there is Cl, so it will be trans, same type of atom up and down, so it will be trans. Okay, and this will be cis. Here the difference, this ethylene diamine, this bond came to this position, okay, and this chlorine came to another position. And here this coordination with the positive charge, that's why we indicating here this coordination number with the positive charge. Okay, so here we discussed geometrical isomerism in bidentate ligand with coordination number 6. Okay. Next one we have to discuss here geometrical isomerism, another type MX2L4. Another type MX2L4. X2L4 mean here central metal atom X2L4. X one type of ligand, 2X and 4L. Totally 6 ligands. So this is coming coordination compound with coordination number 6. Okay, here 2 ligand, here 4 ligand, total 6 ligand. Okay, so this is octahedral complex coordination number 6. Clear? And here this type of coordination compound, example cobalt NH3 4 times Cl2, NH3 coming 4 times and Cl2. Okay, and these are the different isomers exhibited by this type of coordination compound. Look here 2 chlorine atoms are coming same side, so it will be cis. Here 2 chlorines are opposite side, so it will be trans. I told you before, up and down same type of atoms are coming, it will be trans. Okay. So these are opposite side, so same atoms in opposite side. Okay, so here it will be trans. We are focusing this position. Okay, so this same atoms are coming opposite side, so it will be trans. And look here, same atoms are in adjacent side, so it will be cis and trans. Okay. Next one we have to discuss here MA3B3, geometrical isomerism type MA3B3. A3B3, so there is total 6 ligands, so it is octahedral complex and geometric and coordination number 6, octahedral coordination number 6. Example for this type of ligands, cobalt NO2 3 times, NH3 3 times. So look here, these are the structural arrangement of this isomer. Okay, 3 NO2 and 3 NH3. This is the first one. And see here, this is one triangle, single triangle, and same type of ligands are coming each face of single triangle. Okay, each face of single triangle, same type of ligands are coming, NO2, each face. Okay, same triangle, each part there is same type of ligand. Okay, that's why this type of isomers are called facial isomer or called FAC isomer. Same type of ligands are coming in same triangle face. Okay, each corner there will be same type of ligands, that is facial or FAC isomer. Look here, this is above plane and this is below plane, and there are different type of ligands. Here it is NO2 and here it is NH3. And see here, this is another isomer. Here it is called Meridional Isomer or called Mer isomer. Meridional Isomer. Here same type of same type of ligands are coming each corner of a square plane. This is one square plane. Okay, so 3 same type of ligands are coming each corner of a square plane. Okay, and here this type of isomers are called Meridional Isomer or Mer isomer. So here we discuss MA3B3. First one, facial arrangement or FAC arrangement. 3 type of ligands are coming each face of a single triangle, that is facial isomer. And meridional isomer mean 3 same type of ligands are coming in same plane. These 3 ligands are in same plane, Also they are each corner of a square plane. Okay, that's why it is meridional isomer. FAC isomer and meridional isomers are coming MA3B3 coordination number 6. Okay, next one we have to understand here optical isomerism. Optical isomerism. We know stereo isomerism. There are two classifications for stereo isomerism: geometrical isomerism and optical isomerism. Geometrical isomerism already we discussed. Next one we have to discuss here optical isomerism. Okay, both geometrical and optical isomerism mean they have different spatial arrangement but they have same molecular formula. Okay, so let us discuss here optical isomerism. Optical isomerism mean isomers, they rotate plane polarized light. They rotate plane polarized light opposite direction, equally but opposite direction. It's mean imagine A and A dash. These are two isomers. They rotate plane polarized light. One isomer it rotate clockwise direction and another one rotate anti-clockwise direction. Clockwise and anti-clockwise direction. Okay, the rotation will be equal extent but the direction will be different. So isomers, they rotate plane polarized light. Such type of isomers are called optical isomer. Okay, isomer it rotate plane polarized light in clockwise direction. Such type of isomers are called dextro-rotatory isomer. Dextro-rotatory isomer or D isomer. D isomer or dextro-rotatory isomer mean isomer it rotate plane polarized light in clockwise direction. Look here, next one. Isomer it rotate plane polarized light in anti-clockwise direction. This is clockwise direction. Next one opposite, anti-clockwise direction. Such type of isomers are called levorotatory isomer or L isomer. Levorotatory isomer or L isomer. Okay. So here we discuss optical isomers mean isomer it rotate plane polarized light equal extent but opposite direction. Two possibility for its rotation: clockwise direction or anti-clockwise direction. Clockwise rotation mean dextro-rotatory isomer D isomer. Anti-clockwise rotation mean levorotatory isomer or L isomer. Okay. Next one we have to discuss here racemic mixture. Racemic mixture mean a mixture which contain dextro and levorotatory substance in equal extent, 1:1 ratio. Okay, a mixture which contain dextro-rotatory substance and levorotatory isomer. Dextro-rotatory isomer and levorotatory isomer. Okay, same substance but they are different isomer. One is dextro-rotatory isomer and another one levorotatory isomer. Okay, but they are in same ratio, 1:1 ratio. Okay, such type of mixtures are called racemic mixture. So look here, imagine A and A dash. These are isomer. One is dextro-rotatory substance and another one levorotatory substance. Okay, when you mix both isomer in 1:1 ratio, okay, such type of substance, such type of mixture called racemic mixture. Okay. So look here, there is two isomer, one rotate clockwise direction and another one rotate anti-clockwise direction. So both are mixed in equal amount. So their net rotation will be 0. They do not rotate anymore because both dextro-rotatory and levorotatory both are in same extent. So net rotation will be 0. Such type of mixtures are called racemic mixture. Clear? Okay, next one we have to understand here example for optical isomerism. Example for optical isomerism. See here, cobalt ethylene diamine twice. This is example for optical isomerism. Okay, see here, cobalt and 3 ethylene diamine. We know 1 ethylene diamine there will be 2 donor atom. 3 ethylene diamine there will be 6 donor atom. 6 donor atom. So here this is octahedral complex, and here it will be coordination number 6. Coordination number will be 6 because 6 donor atom. Okay, and here you can see this is one isomer, and this isomer exactly mirror image of this one. So optical isomers mean they are mirror image each other. They are mirror image each other, and they are non-superimposable. Non-superimposable mean, look here, this image not matching exactly with this one. Okay, it's flip image this one. You understand? Here this image, when you keep this, when you kept this image over here, this and this not match each other. Here when you take your 2 palm like this, here these 2 palms are 2 palms together, it will be superimposable. Superimposable. They are superimposable. Each fingers are coming together, matching together. So they are superimposable. So when you keep this one here, look here, ethylene diamine this part, but here ethylene diamine here right hand side, and here this ethylene diamine left hand side. So they are non-superimposable. So you have to remember, optical isomers are mirror image and they are non-superimposable. Okay. So here we discussed here, this is one example for optical isomerism, and here coordination number 6. Okay, and here optical isomers are mirror image each other, and they will be non-superimposable. Okay. Okay, so here we already discussed this type of isomerism, MAA3. MAA3 mean one type of ligand, one bidentate ligand repeating 3 times. This already we discussed. Next one we have to discuss here, MAA2X2. MAA2X2 mean one bidentate ligand repeating twice and another 2 ligand. Example, see here, cobalt Cl2 ethylene diamine. Ethylene diamine, it is bidentate ligand, it repeating twice. Then X2. X2 means same type of ligand, Cl2. Okay, so we have to discuss this type of example, MAA2X2. Okay, so look here, cobalt Cl2 ethylene diamine twice. Ethylene diamine twice, each side, left side and right hand side. And here above the plane and below the plane 2 chlorine atom. Look here, when you observe this in mirror, this is the mirror image of this one. So can you observe any change here? Here right hand side ethylene diamine, here ethylene diamine. Here also right hand side and left hand side ethylene diamine. Okay, above the plane, below the plane you can see chlorine. So this type of isomers, there is no change. Okay, its mirror images are superimposable. These mirror images are superimposable. Here ethylene diamine right hand side, here ethylene diamine left hand side, here ethylene diamine right hand side. So their mirror image, these mirror images are non-superimposable. Okay, here in this example they are non-superimposable and these are optically active. These are optical isomer. Optical isomerism. Optically active mean their mirror images are non-superimposable. Mirror images are not matching. This is non-superimposable, and these are really optical isomers. But these are not optical isomers. Okay, I told you for optical isomerism, two isomers should be non-superimposable. You can say these two isomers are superimposable and they are not isomer. These two structures are superimposable, so they are not optical isomerism. Clear? So you have to remember here Ma2X2. So there is one possibility. This type of examples, this type of structures are optically, these are not optical isomers, they are optically inactive. We will say this word, they are optically inactive, and these are optically active. Okay, this type of structure, if these structures are not superimposable, they are optically active and they are optical isomers. Clear? Okay, next one we have to discuss here another type of isomer, MAAX2Y2. MAAX2Y2 mean here one bidentate ligand, then here two same type of ligand repeating twice. Okay, so look here cobalt central metal atom, Cl2 and NH3 twice. This is X2Y2, and here one bidentate ligands also. Okay, so here example for this type of ligand here already given here, and see this structure, cobalt and here NH3, 2 NH3, okay, and ethylene diamine and 2 chlorine. So look here ethylene diamine, it is left side, but here ethylene diamine bidentate ligand right hand side. So when you observe this mirror image, they are non-superimposable, they are optically active, and they are optically isomer. These are optical isomer. So this is example for MAAX2Y2. So remember this example, cobalt, Cl2, ethylene diamine, and NH3 twice. Okay, next one, last point we have to discuss here, optical isomerism in coordination compound with coordination number 4. Okay, optical isomerism in complex with coordination number 4. Coordination number 4 means there is two possibility, octahedral and there will be two possibility, tetrahedral and square planar. Tetrahedral and square planar. Tetrahedral complex only showing optical isomerism. Okay, square planar complex, they are planar, they have in same plane, okay, and they are not showing optical isomerism. Only tetrahedral complex showing optical isomerism, because here tetrahedral complex they have no plane of symmetry. Okay, they have no plane of symmetry, that's why tetrahedral complex only showing optical isomerism. Here example for such type of complex, here bisglycinato nickel 2 complex, bisglycinato, here this is glycinato, this ligand, it is called glycinato, it is coming twice, that's why bisglycinato nickel 2 complex. Okay, this is one example for optical isomerism with coordination number 4. Okay, and this is the structure, look here actually we note coordination number 4. Okay, here nitrogen, this is actually bidentate ligand, nitrogen donate electron pair, and actually it is C double bond O minus, that is COO. So this one of the oxygen and nitrogen donate electron pair to central metal atom, that's why it is bidentate ligand. Okay, so here it is twice. Okay, so there will be 2 nitrogen and 2 oxygen. That's why coordination number 4. So look here, nickel and 2 oxygen and 2 nitrogen. Okay, so they are not in same plane. Okay, this is above the plane and this is below the plane. and that's why here this type of coordination compound with the tetrahedral, they are showing optical isomerism. So here you have to remember only tetrahedral complex shows optical isomerism because they are not in same plane. They have no plane of symmetry. Okay. And square planar complex not showing optical isomerism. This is example, okay, bis-glycinato nickel 2 complex, and this, look here, these are non-superimposable. Look here oxygen and nitrogen left hand side, here oxygen and nitrogen, this is right hand side. So they are not they are mirror image and they are not superimposable. So they are optically active and they are optical isomers. Okay, so these are the things we have to discuss in this video. So you can review the video once again. Okay, so thank you for watching this.